All right. So the main topics we're going to be going over today are based on the last three assignments, right? So one of the first things that we're going to cover is problems that have the following instructions. It's going to say find the values of the trig function indicated. So find the values of the trig function indicated. So basically these are the problems that we started off on Monday, where they would say like find tangent of theta, and then they draw you a picture of a triangle, right? And then you have to figure out what is the ratio for it, okay? So finding the values of the trig function that's indicated. So first one that deals with this instruction, we'll put a sine of theta, and we'll draw a triangle here. We'll put theta up here. Remember, these triangles have to be 90-degree or right triangles, right? So they got to have one 90-degree angle. And we'll put a 5, a 12, a 13 there. So they're just asking us, use this triangle to write the ratio for sine of theta. Now remember, sine and cosine and tangent, you got to remember them as so, ca, to, right? So for sine, meaning opposite over hypotenuse. So we are going to have to try to figure out the sides, right? So the side opposite the 90-degree angle is which one? Which one's my hypotenuse? The 13, right? So we got my hypotenuse right here. Now, according to that angle of theta, which one's my opposite? My 12. So this would be opposite, which relies on 5 being my adjacent side. Now, since they want the sine function, that means I got to use opposite and hypotenuse. So my answer for this one would look like this. So sine of theta is equal to 12 over 13. And that's going to be all you have to do for this problem. Okay, they're not making you figure out the angle. Okay. A lot of times in I think the homework we did on Tuesday, we had to figure out angles as well, okay? But for us, we're just figuring out the ratio, right? Just figure out the ratio. So that's going to be 12 over 13, okay? I'll do one more, and then if you have any questions, we'll kind of stop and see. Let's do this one right here, tangent of theta. Here's my 90-degree, and we'll make this a 3, 4, 5 triangle. So this is a right triangle as well. So remember, the hypotenuse you can identify two different ways, right? The longest side, which makes 5 the hypotenuse, right? Or the side opposite the 90-degree, which again, side opposite the 90-degree would be that one, right? Because that's opposite of the 90-degree angle. So for us, labeling, and just to remind you guys, it's important that you label it right? Because for a couple of students I've helped out, a lot of times they're getting answers wrong and they don't know why. And then when I look at how they label their triangles, it's kind of backwards sometimes, right? The opposite is their adjacent is their opposite. So take the time to understand how to find those things, right? By the way, I forgot to label the angle in here, so let's just put it right here. I just realized I forgot to put that. So which one is the opposite side to my theta? The 4, right? So the opposite side would be here. This would be my adjacent side. So tangent is opposite over adjacent, right, by definition. So I'm just going to write tangent of theta is equal to my opposite side, which would be 4, over my adjacent side, which would be 3. And there you go. All right, so those are our trig ratios. The instructions, like it said, was to find the value of the trig function indicated. So they're just wanting you to write the ratio for sine, the ratio for tangent, maybe the ratio for cosine, depending on the problems. Okay, but on the quiz, according to what I'm seeing here, if you guys came in late, I printed out a different version of it. But according to what I see here, they're going to give you 2 questions on this stuff. Okay, so we just did 2 as an example, but there's going to be 2 questions like this. All you got to do is identify the fraction that goes along with that trig function. Okay? Any questions on these? I know a lot of people have told me that they didn't find this stuff too difficult, so that's good. This is trig. Trig doesn't always turn out this easy, just so you know. It's just right triangle trigonometry is pretty straightforward. It's not too tricky, so that's good. Eventually, you'll get into other stuff with scaling triangles and stuff, like other types of triangles that require bigger formulas. These formulas are a lot simpler, so a lot of people like this stuff. All right, so let's go to the next set of problems that you're going to see. And these say find the measure of the side. So find the measure of the side indicated. And they're going to want us to round to the nearest tenth. Okay, so round to the nearest tenth. So this is why I told you guys, if you wanted to get a calculator, feel free, because that way you can calculate it and do the rounding yourself, right? So, but we're only going to be finding the sides, and then after this we'll do finding the angles, right? And then after that we'll do like one word problem, like the stuff that we were doing yesterday. Remember, the word problems are basically the homework from Tuesday, just in words, right? So it's not like you had to learn anything brand new yesterday. It was the same thing. It was just a picture versus, you had to draw a picture versus a picture being given to you. So for this one right here, we'll put number 3. You're going to get, I'm just looking really quick, you're going to get 3 of these types of problems. All right, so if this is, let's say that's a 4, and this is a 7, or not a 7, I'm sorry, let's call this an x, and put theta here. And actually, theta has to be a degree, so let's make it a 54 degrees, right there. Because we're trying to solve for the side, not for the angle. So initially I put the theta there, thinking I was going to solve for the angle. So we have a triangle here. It has a degree of 54 degrees on one of the angles. A side is on the bottom is 4, and then we have a missing x value. Okay? Remember, it's still important that you guys label your triangle, because labeling is going to tell you what you should do, right? Sine, cosine, or tangent. So which is my hypotenuse, x, 4, or the empty side? X, right? The x. So this is going to be my hypotenuse. Which one is my opposite, the empty side or the 4? It's the empty side, right? The empty side. And you got to shoot straight across, right? So this is going to be opposite to my 54 degree angle. So that makes this adjacent. Which trig function am I using if it's adjacent and hypotenuse that's labeled? So my cosine, right? Cosine is the AH, right? Adjacent hypotenuse. So I'm going to use the cosine of 54 degrees. So cosine of 54 degrees is equal to adjacent, which is 4 over x. As usual, you got to solve for x, so you're going to have to move things around. So you can get x by itself. So I'm going to get the x, and I'm going to multiply it to the left-hand side. So let me kind of write that out here. Multiplying this out, that gives me x cosine of 54 degrees is equal to 4. Now again, if you want to figure out cosine of 54 numerically, you can. What I'll do is I'm going to do it one way, and then on the next one I'll do it differently. Here I'm going to figure out cosine of 54. So I'm just going to get my calculator, right? Turn it on, type in cosine of 54, and it gives me 0.5877852523. I don't need that big old number, but let me write some of the digits. So 0.587785. Okay, that's cosine of 54. Well, what do I do to get x by itself? Yeah, I want to divide by that decimal value, right? So let's divide both sides by this. 0.587785. So that gives me x equal to, and now let me write this out here. I'm curious if they have an easy flip button here, but they don't. So 4 divided by 0.587785 is 6.805. But if they said that they want me to round it to the nearest tenth, what's my answer? 6.8. So all right, so here we go. 6.8. Notice for this one, I decided to calculate cosine of 54 first. Okay? I decided to calculate it first. That way I don't have to worry about doing it later. Now for the next problem that we're going to try, I'm going to calculate the trig function after. Okay? And you'll notice it's the same thing. It's just you're not getting this big decimal next to the x value right away. All right? So any questions on this one? So we're going to do one more like this. So let me move up. Question 4. Let's try a question that looks like this. We'll make theta, sorry, I don't want to write theta. Let's say 23 degrees. Okay, so there's my 23 degrees. And what function did we use? We used cosine, right? So let's use, let's try that. I don't want to use cosine again, so we'll use a different function right now. All right, so again, which one is my hypotenuse? The x, the 2, or the empty side? Empty side. Okay, so this is my hypotenuse. Now, according to 23 degrees, which one is my opposite? The 2. Okay, the 2. It goes straight across. So this has to be adjacent. Okay, so it's opposite and adjacent. Those are the things that have values. So which trig function is that? Yeah, it's going to be tangent, right? So tangent of 23 degrees is equal to 2 over x. Now remember, sometimes the x value doesn't end up in the denominator. Sometimes it's on top, so all you have to do is multiply a number and you're done. I'm doing these with the denominator with x because those are the tougher ones for some people, so I'd rather do 2 of the tougher ones instead of like an easy one that most people don't struggle with, right? But we'll go with the ones that I tend to see more people make mistakes on. So the x, we're going to throw that over. Okay, so multiply, that gives me x times tangent of 23 degrees is equal to 2. Now again, I'm not going to calculate tangent of 23. What I'm going to do is I'm going to divide tangent of 23 as a whole, okay? I'm not going to make it into a decimal. I'm just going to write it out like this. Because that's going to cancel on the left side, okay? This will cancel out. All you have left is x and then whatever the result of 2 divided by tangent of 23 is. So I'm going to go ahead and type that in, 2 divided by tangent of 23. And I get 4.711. Actually, 4.7117. There's a whole bunch of other numbers after that. What is my rounded tenth value? 4.7, right? So here we go. Right. So again, you will have 3 of these types of problems, okay, where you're just finding the side. Now from there, they're going to kind of change it up and they're going to say, okay, we've been doing triangle stuff. Let's do some conversions. So they're going to make you convert angles and radians, all right? One of each. So we'll do one of each. So I'm going to put right here, convert from radians to degrees or degrees to radians, depending on what they give you, right? If you see that it says 45 degrees, then obviously that's a degree, so you're going to want to change it to radians, right? If they just give you like pi over 6, well, that's a radian because it doesn't have a little degree symbol on it, right? So if it has a degree symbol, then it's a degree. If it doesn't have a degree symbol, then it's a radian. And they're not going to tell you on the test. So you're just going to have to know. So here's number 5. So is this a degree or a radian? It is a radian, right? Because it doesn't have a little degree symbol, this little circle thing up here, right? A little symbol. So this is just a radian, pi over 3. So the way we convert it, it's a little formula, right? A very simple formula. You're going to multiply times 180 degrees over pi. Now remember, the pi values will cancel out because they are diagonal to each other, so you can't get rid of them. So you're just left with 180 degrees divided by 3. If you want to put that in your calculator, your answer comes out to 60. So this would be 60 degrees. You'll have one problem like that, okay? Where they're going to give you the radian, all you got to do is convert it, okay? Remember, the conversion factor is basically right here. You're multiplying times 180 over pi, okay? And you do the opposite when you're going from degrees to radians, right? You're going to multiply by pi over 180 for this next one, all right? So number 6. So let's do 20 degrees. So again, this one is pretty obvious. It's a degree because there's a degree symbol, right? So 20 degrees. So I want to change it to radians then. So 20 degrees times pi over 180 degrees. Now, some people got a little confused when I taught this the first time. I was watching them do the work, and they're like, I don't understand why you went from, and let me show you. From 20 times pi over 180, I went 2 pi over 18. Okay? And then from there, I reduced 2 over 18. That's 1/9, right? So that would be pi over 9. And a lot of people were wondering, like, where did this come from? Why did we have to do that? Remember, when I was teaching this to you guys, I wasn't using a calculator, right? So I was reducing myself. I would divide by 10, right? 20 and 180, I can reduce them by 10. So 20 divided by 10 is 2. 180 divided by 10 is 18. So I did that in my head, and then I said, oh, 2 over 18 is 1/9. So it took me a couple steps because I was just doing it in my head, right? Whereas if you had a calculator, I could literally just type in 20, or I can hit my my fraction button. So I can hit the fraction button that you guys have right here. And then I would have typed in 20 pi, and then over 180. So what is that? I have to delete this piece. Hold on, 180. And when I hit enter, it gives me 1/9 pi. On the calculator, it gives me this. Okay? Which is the same thing as that. But I think I told you guys yesterday, if I didn't tell you, I was telling other classes. I don't like the way the one on the right side looks. You never see us writing in trigonometry. We will never write our radians like that. It looks weird. Okay? We like our radians to have the pi up on top. So we'll write like 11 pi over 3, right? 5 pi over 2. We don't write 5 halves pi. That looks weird, right? So not that it's wrong, and if you happen to write that on your test tomorrow, I'm not going to be like, oh, you wrote it the wrong way, it's wrong. Like, no, it's still correct. But if you can do me a favor and try to keep the pi values in the numerator, okay? And that just, it looks proper. That's the way it's supposed to look, okay? So if you want to write it the other way, I'll know you did it on a calculator, which is fine. You're supposed to be able to use these. But I'll know you did it on a calculator because even my calculator, even though I put it on top, it still put it to the side, okay? So either way is okay, but I really do prefer that you guys put it in the numerator, all right? So you have 2 questions like this, and then the very last set of questions, and I'm not really going to do a bunch of these because there's supposed to be like 3 of the solve for angles, 2 of the word problems. So I'm just going to do one word problem because the word problem includes solving for angles. Okay? So a lot of times they'll have you do that stuff, solving for angles and things like that within the problem. So let me give you a word problem to work on, and then we're going to be done with the review for you guys. If you have questions after that, we can definitely cover some more if we need to, or if you just want to work on homework, that's fine. So here we go. An electrical pole. So electrical pole can be like those, those big brown poles that have all the cabling on them, right? So an electrical pole that is 80 feet tall casts a shadow that is 120 feet long. So an electrical pole that is 80 feet tall casts a shadow that is 120 feet long. Find the angle of elevation find the angle of elevation of the sun to the nearest degree. So like I said, I'm not going to do any problems where it's just a pre-drawn triangle with the missing angle and then you got to solve it. The reason why is because when we do this, it's going to have that problem, right? So I don't need to do a bunch of those and then do another problem that's the same thing, right? Let's just go with the most complicated problem, and you can see it from there, and then we'll practice doing the other ones at the same time. So we'll kind of kill two birds with one stone, as they say, right? So an electrical pole that is 80 feet tall casts a shadow that's 120 feet long. Find the angle of elevation of the sun to the nearest degree. Now remember, angle of elevation means you're looking straight, and then if you elevate your head, it goes upwards, right? So this angle is going to be opening upwards. So we're going to draw a picture here, an electrical post. So again, in math books, they always make it look so much nicer, but it doesn't have to be a perfect picture, just a picture, okay? So there you go. There's a post, there's the ground. They say it's casting a shadow that's 120 feet long. So I'm going to kind of just make a squiggly line to pretend that's our shadow here, okay? And then they say that the sun, obviously, is out there. That's helping it cast that shadow. So I'm just going to use a little picture here to help us out with that. So the sun would be basically casting a shadow that goes up to there, right? Using the top of that post, it's basically creating a shadow using that line, okay? Now they said find the angle of elevation. So here it is, angle of elevation. They said that the pole is 80 feet tall and the shadow is 120 feet long. Right, so this is a picture that I'm drawing. I mean, you can make it look nicer, or you could just draw a straight out triangle without anything else, right? It depends on what you want to do. So, without labeling any sides, which trig function am I going to use? Yeah, it's going to be tangent, right? I'll label them right now just in case, but this is my 90-degree angle right here, which makes this the hypotenuse, right? But notice the hypotenuse is not being used. The only trig function that does not have a hypotenuse in it is tangent, right? This would be my opposite. This would be my adjacent side. Okay, so it's opposite and adjacent. That is a tangent function. So tangent of theta is 80 over 120. Now remember, you can reduce that. You can reduce that by 40, right? So that's going to become 2/3. Again, you don't have to. Your calculator can do it for you, but I always prefer you guys try to simplify the math before you start working on everything, right? Make the numbers smaller if you can. So that becomes a 2/3. To get theta by itself, we're just going to transfer the tangent over to the other side. So tangent inverse of 2/3, and then this is where you do depend on your calculator, right? So remember, to find your inverse, you're going to hit shift tangent. So shift tangent of 2/3. They didn't tell me, wait, did I write that nearest degree? Yeah, I did. Okay. I forgot if I put that. So I get 33 .69006.753. That's what I get. They want me to round it to the nearest degree. So what is that? 34. Yeah, 34 degrees. And there we go. So I'm going to zoom out just a bit here. Okay. And then I'll zoom back in. But just to show you guys, a triangle like this that's given to you guys, without the picture, is what the other problems look like. There's no picture. It's just the triangle with sides labeled, a missing angle, and you just got to figure out which one, sine, cosine, tangent, which one am I using. This one is just, you had to draw a picture, and then from that picture, create your own triangle, right? So that's the only difference between this and the other ones that, like I said, I wasn't going to do, because this will go over that same process. So once you find your angle, don't forget you're going to have to move whatever it is, sine, cosine, or tangent, over to use its inverse, right? Use your calculator to figure out your angle. And if it asks you to round to the 10th, then round to the 10th, round to the whole number, then round to the whole number, right? In our case, they said nearest degree. So 34 would be the correct answer for that. Okay? So you guys have a total of 12 questions for tomorrow. Okay, like I said, this is basically right here. This is your quiz with different numbers and stuff like that, right? Different stories and stuff like that. So it's basically a carbon copy of it. I don't even know if you guys know what a carbon copy is. I'll explain it after. But it's a copy of the quiz that you guys are gonna have, just with different numbers. So as long as you can work on this, you practice this tonight, right? When you go home, just kind of work on them again. And if you find that you're able to do this stuff, you should be good for tomorrow, okay? Because the questions don't get much harder than this stuff. It's the same idea, right? I always try to show you guys stuff that's challenging or middle of the road. I try not to just show you the easy stuff, because then you feel confident because it's easy, and then you take the quiz and it gets harder and you're like, he didn't show us this, right? So I always try to show you the tougher stuff just to make sure that you guys are okay with it. So, you guys have any questions? All right, so the rest of the time, if you guys have homework you got to finish, work on that. If you're missing a homework assignment, right there on the side, you got the basket. You can go pick one up from either Monday, Tuesday, or Wednesday. Or if you have to ask me anything, just let me know. If you need calculators, there's some up here and over there.